Let us find out the equation for the efficiency of the rectifier. We are interested this efficiency in case of the full wave rectifier. And before starting this, I want that all of you should remember the topics which we have covered. So this I am just showing you just to recall this. Here we have seen that in case of the rectifier, output is DC and input is AC. So whenever we talk about the efficiency, it is given by the ratio of output by input. So output is DC, input is AC. So rectification efficiency is nothing but the DC output power divided by AC input, and this equation will be using here. That's why I want you all to remember this. Okay, so now first of all, as I said, we are interested in getting the value of DC input, sorry, DC output power which we are getting in case of the half wave rectifier. And this DC equation or this DC power can be given by equation EDC multiplied by IDC. It is nothing but the power is equal to voltage into current. But further, this EDC can be written like IDC into RL, and that's why we can have the equation directly like IDC square multiplied by RL. Now the equation for IDC, we know in case of the full wave rectifier, the value of IDC is given by twice Im by pi. This already we derived in the previous session, right? Now it's a square, and that's why this term is squared multiplied by resistor RL. Further solving this, the square of 2 is 4 Im square divided by pi square multiplied by RL. Now the equation of Im we all should remember. If not remembering, we can take it from the previous session. So Im is equal to Vm by Rs plus Rf plus RL, where the meaning of all this term is shown in the diagram. So this equation I will write directly here. So after putting the equation of Im, I will be getting the equation of PDC is equal to 4 by pi square Vm square divided by the resistors Rs plus Rf plus RL and its square, and this term will be multiplied by this resistor RL, and that's why this RL as it is. So this is the output which we are getting for the rectifier. Similarly, we are interested in getting the equation for the AC input which we are applying. So that's why AC input is given by PAC is equal to, whenever we talk about the AC, we use the equation of current as a IRMS. So it is I square into R. So we have this I square into R. Now what is R here? So all the resistors we should consider here, Rf plus Rs plus RL, where what are this resistor I have already shown you in the diagram. Again we know for full wave rectifier IRMS is given by Im by root 2. This equation also we have derived earlier. So putting this value here, we will be getting the equation of PAC, which is nothing but the applied AC input power. Now this, if I put here directly, I will be getting Im square divided by 2 in bracket all these resistors Rf plus Rs plus RL. So this is the equation for PAC. Further, if you remember, we already have the equation of Im in terms of Vm. So that equation I have to write here. So if I write this equation here, the equation further gets is this. We have Vm square divided by this 2 I will write here as it is. Now Im equation is remaining still, so it is Rf plus Rs plus RL and its square, right? So this term is completed, still it is remaining, so it is now multiplied with RF plus RS plus RL, right? Now this will cancel, means this two term will cancel, and this square will be removed, and only this term will remain in the denominator. I will write here. So finally what we are getting is the equation of AC input which we are applying to the full wave rectifier. After solving this, we will be getting this Vm square divided by 2, and now we are having this RF plus RS plus RL. So this is what we are having, the AC input, and this is the DC output which we are getting. Now the efficiency formula we can write: efficiency of any circuit can be output by input. Here we are having DC at the output, so that's why PDC output divided by PAC input, and we have now got the equation of PAC, PDC and PAC. These equations we will be writing as they are here. So now the equation for PDC I am writing here. It is 4 divided by pi square, this equation. Then here we can write as a Vm, let me write it first, Vm square into RL divided by RS plus RF plus RL, its square. This is the DC. Now divided by this AC, means this. So again it is Vm square divided by 2 in bracket RF plus RS plus RL, bracket complete, right? Now we have to solve this. So simply we can see Vm square will cancel each other. This bracket and will cancel, so that the square term will be removed. And further solving this completely, what I am getting is, it is equal to 8 RL. You should solve yourself also, huh? So here I am getting 8 RL. In the denominator what is remaining? So this pi square in bracket. So this bracket and this square, if cancelled, the square is removed, and only we are remaining with RS plus RF plus RL, right? Now again, as we know, this RS is the series, it is the secondary resistance, RF is the diode resistance, which are very small, and that's why this term we neglect. We know RS plus RF are very small as compared to the value of load resistance, right? So neglect them. So we are going to neglect these two terms. So with this, what we are remaining is efficiency is equal to 8 RL divided by pi square, and these two are neglected, that's why it is RL. Further RL will cancel each other, and we are remaining with 8 by pi square, right? Now putting the value of pi square here, we can get the final value of the efficiency, which comes to be in percentage. If you have, it comes to be 81.2%, right? This I am saying that this I have taken in percentage, means whatever the result of this I have got, that is multiplied by percentage, and that's why we say that this is the maximum value of the efficiency we get in case of the full wave rectifier. So that's why I can write here, this is percentage efficiency maximum, that is 81.2%.